Well, finally, I'm going to get around to doing some differential equation work. We'll say that in the course of time, in the last few weeks, I've been able to come on campus to do my videos. And in that process, I've now learned that I can manipulate my way anywhere in this particular building and touch nothing except for with the soles of my shoes. I open doors that way, I close doors that way. I use only my key, which is in my pocket, and I never touch the door when I open it. And just overall, it's changed the way that I go up and down stairs because I don't even touch the railings. But anyway, been an interesting few weeks. So I'm going to start talking about section 2.6 in the differential equation books. And this section is called compartmental analysis. Now the basic idea here is that we have a compartment, a space, whatever you want to call it, where we have a tank holding something, etc., whatever, and we have something flowing in and something flowing out. And this would be the input, and this would be the output. And in some cases, provided that what we have, let's say what we have flowing in has a concentration. Let's say that we're talking about, I don't know, brine for, let's say we've got a saltwater fish tank. And we want to be able to circulate fresh brine into that tank so that, so the water itself gets kind of changed out over time. Well, we know that the concentration of water that's correct for the fish tank, and let's just make up a number, is 4 pounds per gallon. Now, if what we push in over here has 4 pounds per gallon, and what we push out over here is 4 pounds per gallon, well, obviously whatever, if what is in here is 4 pounds per gallon, and I just opened a drain on this side, what would come out would have a concentration of 4 pounds per gallon. Okay? And if what I'm replacing it with is also 4 pounds of salt per gallon, then I would just maintain this 4 pounds per gallon concentration. Also, in addition to the concentration that I also have the rate that liquid is coming in here. So let's say it's 4 pounds per gallon, but let's say it's in terms of liquid, let's say that I have 2 gallons per minute. Seems a little bit high. Okay. As long as what I have over on this side is 2 gallons per minute also. Then basically whatever flows in one side, I've got the same amount going out the other side. The level of water in the tank here is going to stay the same because I got the same amount pouring out as pouring in. And if the concentrations are the same, then what's in there is going to maintain a concentration of 4 pounds per gallon. Now, from an equation perspective, we could look at this and say, well, if X, let's see, yeah, X right here is the 4 pounds per gallon in the tank. Concentration in tank. And if that's 4 pounds per gallon and the input here, I of T, which I've also said is 4 pounds per gallon, the change in the concentration is given by this. Okay, the concentration being this X, dx dt is equal to whatever the input concentration is minus the output concentration multiplied by a fraction that is the fractional part that left the tank. Okay, so obviously as we have water moving through here, some portion of the tank is going to leave here, and that fraction that leaves is what K is. Well, in the case that I've outlined here, where they're all 4 pounds per gallon, well, then this value right here is going to be 0. I'm going to have dx dt equaling 0. There's not going to be a change in the concentration, right? If x is the concentration of salt in the tank, the change in concentration is going to be equal to 0. And we can see that fairly easily. But if we do something different here, and the input concentration is some different concentration than what the output concentration is, or what the tank's concentration is. For instance, if I change this and said, okay, I'm not going to have 4 pounds per gallon, I'm going to have 2 pounds per gallon. Now, if I go 2 pounds per gallon, over time, the concentration in the tank is going to decrease, right? It starts at 4 pounds per gallon. Initially, when I start pouring this out, 4 pounds per gallon is what the concentration is going out. But since only 2 pounds per gallon is coming in, over time, eventually, if we let this system run like that long enough, eventually the tank will have a concentration of 2 pounds per gallon only. So we can set up an equation starting at the same place where we want to set up this type of situation. So,